Welcome back to The Learning Curve. Today we're diving into a key topic in IGCSE Physics, reflection and refraction. Let's start with reflection, something we see every day in mirrors. When a light ray hits a surface like a mirror, some or all of it is reflected. But which rays get reflected? It depends on the surface. Smooth, shiny surfaces reflect more light. Rough surfaces scatter it in all directions. This is called diffuse reflection. Now, the important rule here is the law of reflection. The angle of incidence equals the angle of reflection. To draw it, first draw the normal, a dashed line perpendicular to the surface. Draw the incident ray coming at an angle to the normal. Then draw the reflected ray, leaving at the same angle on the other side of the normal. Always measure the angle from the normal, not the surface. Now let's look at refraction. This happens when light bends as it passes from one material into another. Why does it happen? It's because light changes speed in different materials. In denser materials like water or glass, light slows down. But here's the key point. Light always travels at the maximum possible speed. In a vacuum, that's roughly 300,000 meters per second. In other media, it's slower due to interactions with atoms. Let's make a drawing. A ray moves from air into water. It bends towards the normal because it slows down. If it goes from water into air, however, it bends away from the normal as it speeds up. The difference in angle is due to the change in speed. To calculate angles in refraction, we use Snell's law. n1 times sine of angle 1 equals to n2 times sine of angle 2. n1 and n2 are the refractive indices of the two media. Angle 1 is the angle of incidence, and angle 2 is the angle of refraction. Here's an example. Light enters glass with refractive index of 1.5 from air with a refractive index of 1 at an angle of incidence of 30 degrees. To calculate the angle of refraction, we rearrange the formula. Now we substitute the values. Don't forget to use the inverse sign to get the angle of refraction. So, as you can see, the light bends towards the normal as it enters a denser medium where its speed is decreased. Have you ever noticed how at sunset you can see the reflection of the sun of the water, but not at midday? That's due to total internal reflection. When light travels from a less dense material into a denser material, like air to water, it bends towards the normal. If the angle of incidence is large enough, light doesn't enter the water at all. It reflects instead. This happens when the angle of incidence reaches the critical angle. To find the critical angle, we can use the following formula. Sine of the critical angle is n2 over n1, where n2 is the refractive index of air and n1 is the refractive index of water. Substituting these values, we find that the critical angle for a water-air boundary is 48.8 degrees. So if the sun shines on the water surface at an angle of greater than 49 degrees, it will reflect off it. Question 1. A ray of light enters a glass block at an angle of incidence of 40 degrees. The refractive index of glass is 1.5. Draw a diagram showing the angle of incidence and the angle of refraction. Pause the video and give it a try. We start by drawing the boundary and the normal. Next, we draw the incoming ray and label the angle of incidence. Finally, we draw the ray entering the glass block, bending towards the normal as it slows down. Tip: always draw the normal line and show the wave bending in the correct way depending on the change in speed. Question 2. Light enters water with refractive index of 1.33 from air with refractive index of 1 at an angle of 45 degrees. What is the angle of refraction? Pause the video and give it a try. To answer this, we simply use Snell's law and substitute the values. Finally, we use inverse sine to get the angle of 32.1 degrees. And that's it. You've just learned the key concepts of reflection and refraction for your IGCSE Physics exam. Practice drawing ray diagrams and using Snell's law. These questions are exam favorites. For more tips, practice papers and notes, check out our website at learningcurve.podia.com. And don't forget to like, subscribe and hit the bell for more IGCSE science help from the Learning Curve.